This is a video on intersection and collision. The question states, two particles travel along the curves r of t and w of t. Determine if their paths intersect and if they collide. So the vector-valued functions that give the particles paths are r of t is 2t I plus t minus 1 j plus t squared plus 1 k. And w of t is t squared plus 2 I plus t squared minus 2 j plus t squared plus 6 k. So if two curves intersect and they're defined by vector-valued functions, that means there will be some value a for the r of t curve and some value of b for the w of t curve, such that the vectors r of a and w of b are equal to each other. So r of a equals w of b. So if these vectors are equal, that means each of those components are equal when we plug in a for t in the r equation and b for t in the w equation. So the first component, if I plug in a, I get 2a, and for the second vector, if I plug in b, I get b squared plus 2. So I could set 2a equal b squared plus 2. For the second component, I get a minus 1, and I get b squared minus 2. So I set a minus 1 equals b squared minus 2. For the third component, I get a squared plus 1, and I get b squared plus 6. So I set a squared plus 1 equals b squared plus 6. So that gives us 3 equations and 2 unknowns. We need to see if they have a solution for a and b. And if they do, then we know their paths intersect. Moreover, if that solution is such that a is equal to b, that would mean that they intersect at the same time, so they collide. So I can solve for b squared in this first equation and get b squared equals 2a minus 2. And in the second equation, I can add 2 and get b squared is equal to a plus 1. So they're both b squared, so I can set them equal to each other. And I get 2a minus 2 is equal to a plus 1. So I can add 2 to both sides and subtract a, and I get that a equals 3. Since b squared is a plus 1 and a is 3, b squared is 4. So that tells us that b is equal to plus or minus 2. So now to find out if these paths intersect, I can plug in a equals 3 and b equals plus or minus 2 into the third equation to see if this is true or not. So I plug in 3 for a, and I get 3 squared plus 1, that's 9 plus 1 or 10. And I plug in plus or minus 2 for b, and either plus or minus 2, if I square it, I get 4, and 4 plus 6 is 10. So it is true that 10 is equal to 10. So that means that the paths do intersect. On the other hand, they intersect for time a equals 3 for the first vector-valued function, and for time b equals plus or minus 2 for the second vector-valued function. So that means the times are different. So although they intersect, they don't intersect at the same time. So that means they don't collide. To find out what point they intersect at, I can just plug in 3 in for t in the r of t equation, and I get 2 times 3, so that's 6i, plus 3 minus 1, or 2j, plus 3 squared plus 1, which is 10k. So I can conclude that the paths intersect at the point 6, 2, 10, but the particles do not collide. And I'm done with the problem.